Thank you. Can you hear me? Okay. After such a nice session with two of the best speakers, it will be difficult to match them. But anyway, I'll try my best. Anyway, the main issue in smart spectrum sensing is about our devices, the devices that we all carry with us, and most of them are connected wirelessly. And we don't imagine that each device, even the pointer here, is using a spectrum, part of the spectrum that is allocated to wireless communications. And we are now increasing more and more of wireless devices coming in. And with the advent of Internet of Things and machine-to-machine communications, most of them will be connected also wirelessly. So we will be actually running out of spectrum or running out of bandwidths. So that's when we at CSIR now have the ideas that came up to say, how do we make sure that this shared spectrum or the spectrum that's available, it's as a national resource, how can we share it? Just like we share roads, isn't it? Roads have never been allocated to a car type or a car model, isn't it? Everybody uses it. So just like that in the future, we will have to share this spectrum that is a highway for enabling the services that we all run with our devices. So that is the main message of this talk. So when we say radio frequency spectrum, it's actually a national resource which is scarce, which has to be managed wisely, especially when it comes in the future, when we have the devices becoming more versatile, which do video and data and voice type of communications, and also that we would like to allocate this spectrum dynamically. And then at the same time also we would like to see that this spectrum is actually a very expensive commodity, because most of the time, if you have seen the bidding for spectrum, it's actually $1 billion bidding that the operators do. But when you see the actual usage of the different allocations, then you become very surprised that such a scarce spectrum resource is being utilized very low compared to the requirements that we have. So, for example, in one of the projects that we did for smart grid work for ESCOM, we analyzed in South Africa what are the type of spectrum availabilities, and this is the result of the analysis that we have done. Okay. Should I put it? Okay. So what we did is that we did for each municipality in South Africa, we did analysis of TV white space availability. This is just a spectrum between the 470 to 800 megahertz band. And we could see that there is a lot of spectrum, but at the same time, most of these municipalities are not connected to internet. So there is a large portion of spectrum that is very important to utilize, especially when we see that we are going to have 50 billion devices with machine-to-machine communications and 7 billion cellular connectivity and more of next generation broadband connectivity to rural communities. So the static allocation of spectrum looks like this. So you can imagine that how the spectrum allocation is going is that you identify a service, for example, let us say flight services, and then you allocate it a band of spectrum. But the regulator will not usually go and check how an operator is utilizing that spectrum. So there is a large chunk of spectrum that is not utilized. But at the same time, as we say, we are running into problems of spectrum capacity or the bandwidth capacity in the future. So this is a type of spectrum allocation, for example, in Sweden that they have done. And you can see here there is the UHF and VHF band, which we now utilize for testing spectrum sharing. So at the same time, we have a broadband conundrum. We have the coastal areas of Africa, for example, are connected with terabytes of bandwidth, but we still have not money to get inland all this bandwidth that is available. So we have the future broadband, wireless RDI research that we are trying to see, and there are these terabytes of bandwidth, that is submarine cable bandwidth, that's available in each coastal region of Africa. How do we get it inland? There are actually initiatives that CSIR has done. SUNRAIN is one, the Southern Africa network of research and education, where in South Africa, for example, there is a lot of SUNRAIN connectivity from the submarine cables inland. But that's not enough, because there are so many rural areas also that are not connected. So there was another initiative, the Broadband for All initiative, that was connecting also using wireless mesh networks, connecting different type of rural communities and giving services to schools and municipalities. But that's not enough in the future, in my opinion, because we need to get the industry also involved in this and make them understand that the technologies that they have should be addressing even rural communities. So the mobile industry has to be involved in this, but not only to keep the profit margins, but also to connect the rural areas so that they get also the benefit of internet connectivity. And as we all know, broadband connectivity also is connected to GDP growth. So we have seen the mobile revolution. We have seen how only voice and messaging services were available during the 1990s. And then we've got the 3G data and positioning that has come in. And then 4G has come in also in the later. And we are now also looking in 5G. But in all this, you can easily see that the static allocation of spectrum has actually affected the usage and also the services that could have happened in these generations. Because there was a limited amount of bandwidth that is allocated, and the services, when they increase, especially in 4G now, the video streaming functions, that they have to be limited, because this bandwidth towards the base stations is limited. So it has to be shared. Because of that, the services have to be limited. But what we should do is that we should let, now in 5G, for example, they are looking for spectrum agility. There is a spectrum toolbox that is being proposed, but there is a lot of reluctance from the industry. Industry is always looking into the legacy equipment because they have already invested in it, and the return investment they have got it already, but it's actually a printing machine, a money printing machine for them. So they don't want to go forward and implement this type of spectrum agile networks, but there is a proposal for that. So I hope both the regulators and the government institutions and the industry sees that we cannot increase the data traffic by 1,000 times by only having static allocation of spectrum. This has to be clear for the industry and for the regulators and everything. And it has been proposed such a spectrum toolbox for 5G, but still there is a lot of reluctance from the industry to accept it. But we cannot go out of it, because we are now thinking of 50 billion devices. This is actually an iceberg that's coming to hit the networks of the future. And there is also increased bandwidth requirement for each wireless service. The actual relevant services that we think about, e-health, e-education, e-bank, and e-government, they require at least 2 megabits or 4 megabits per second connectivity. And if we think all communities being connected, then the bandwidth is going to increase. And then we are going to get also more and more broadband subscribers, because we want to connect the rural communities, especially in developing countries, which are only 21% connected. So the 79% needs connectivity. So what we did at the CSIR is to look into a smart spectrum sharing tool, which we developed, and which we call the CSIR Intelligent Spectrum Database and coexistent tool. What I didn't tell you here is that when you say spectrum sharing, then you have to make sure that you don't interfere with the one you share spectrum. Because now we have 2 test beds in South Africa. One is in Western Cape and one is in Limpopo. And these networks have to share spectrum with TV broadcasters. But we could make that happen, or we get license from ICASA by ensuring that there is no interference between the TV wide-space network that we have built and the TV broadcasting stations there. So this is what we have done with this database. That the database, you can be at anywhere in South Africa and tell and query this database to see whether at that location you want to build a network, there is enough spectrum for you to use it without interfering with the primary network. So this is a coexistent tool. It's not only a spectrum database, but also a coexistent tool. So how do we increase? This is actually Shannon's theory in block diagrams, because we did a lot of spectral efficiency using speech coding, for example, video coding. All those are spectral efficiency measures. And now we are increasing the spectrum using spectrum databases. And then there's also a lot of densification and small cell networks that is being proposed by 5G. So if we combine all this, we might be able to meet this 1,000 times data traffic increase that we can expect in 2020. So the system looks like this, how we build it. And we have used data from the regulatory environment, and we have used data from the broadcasting stations. And we now model it. This is a model-based system. We model it accurately using radio propagation models, different type of radio propagation models to fit the terrain models that we have also. And then we have built in the TV wide-space database. And we have given the TV wide-space database a protocol. We have designed a protocol called the Protocol for Accessing Wide Spaces, so that the devices, the network devices, will be able to query the database and get the available spectrum. So this is a technology demo, and we have also patented this technology at the CSIR, and it's also hosted now at the CHPC, the Center for High Performance Computing, and it can be accessed publicly using this URL. So using this tool, we have tried to see in South Africa, for example, how many spectrum channels that are possible at different locations in South Africa. And also we have also had a lot of discussion with ICASA and on how to, they can use it for spectrum management, because they need also to have, the information to be able to license the spectrum to users like, the wireless ISPs and other users. They need to be able to do that. So the technology can be used not only just to access the spectrum, but also to monitor the networks that are operating. So one of the advantages of this is that the networks that will be built will be affordable, because one of the problems that we have in many developing countries, even in South Africa, is affordability. Even the industry is saying that going to rural areas, we will not get the profit margins that we plan, or the techno-economics does not fit. That is the term they use actually. The techno-economics does not fit for rural areas. But the rural areas also need connectivity. So how do we make that happen? Then it's by building affordable networks, affordable broadband networks. So using that technology, the TV white space technology, we have now 2 test beds in Western Cape and Limpopo. We have connected 10 schools in Limpopo, 10 schools in Western Cape, and in Limpopo 6. And we are serving now around 25,000 students with an average of 4 megabits per second. So we are also happy that we have never interfered, because if we had interfered with the primary users, then ICASA would have switched off, or they would have taken the test license that we have got. But for us, this is actually the starting story for global spectrum sharing, because now FCC and Ofcom, all of them are referring our test beds as good examples, as good practices of making TV white spaces work. And at the same time also, we have got a number of clients from other African countries who have asked us, we want to use TV white space networks to connect our rural communities also, because it's almost the same problem in many of the African countries. So this is one of the impacts of the research and development that has been done in Cape Town, near Cape Town or Western Cape. We have a school that is connected, and they have connected their labs to the internet, and they are using it. So one of the impacts, as you have heard, the CEO and the minister and the deputy minister, the deputy prime minister also said that we need to have socio-economic impact on our research. This is one of the socio-economic impacts that we have done. So when having the clients, the request from the other African countries, for example, now we have built a database for Ghana, and we are now negotiating with Botswana to build a spectrum database. So we thought maybe it's better to have an Africa-wide spectrum database which we can access using cloud infrastructure, which we get from Happy and his group. And we are envisioning now a database composed of 4 type of databases with SADC and the Eastern Africa communities and Western African communities and the Northern African communities, and be able to provide services to more African countries. So the work that we do, the research and development and innovations that we have done also has attracted several international organizations. One of them is the European Union Ofcom regulator, who is running now a standards and the tools and the standards and policies. They would like to see that the databases that are available, we are actually sitting here with big multinationals competing with them. And I can tell you that we are doing very good, because we had the first test by the AU Ofcom recently, and we passed that test gallantly with competing with big multinationals like Google and Microsoft and all of them. And this one gives us also feedback for the future wireless networks, because they are going to be based on this type of network. Dynamic spectrum access networks and sharing. That's a very important tools. And we get feedback because we are now in the standards and the tools and the policy issues. So in conclusion, I think the full potential of spectrum as a national resource, we have shown it with 2 test beds now in South Africa, and it has been also being performed in several other African countries and also Europe and Asia. So spectrum as a national resource has to be managed well and dynamically. And we have also shown that with test beds in 2 instances in South Africa. And we have also now got a lot of requests from different wide space device manufacturers, Carlson Wireless in the US, and 6 Harmonics is in Canada, and Redline now is working with Parsec in South Africa. We are also working with that. And we have been involved in this protocol development to access the data, the spectrum database. In future, we are trying to see what we did in the TV band frequencies. Can it be replicated in other bands? Because there is a lot of spectrum also which is free in many other bands. And also that we would like to see if we can free more bands so that we also contribute to the solving this 1,000 times traffic increase. And we are working with several international organizations to make the standards for future wireless ICT research and development that we are doing. And we are also looking for potential industrial partners, because this database has to be in the long term be commercialized and become an industry, in my opinion, in South Africa. And also we have a number of stakeholders which we are engaging with. And so in the future, I would like to see that we the technology that we develop actually makes a positive change for the future. And it's not like, the future generation is going to judge us. How did we use this technology to make it, to make a better world? So this is my last slide, and thank you.